So today we're going to be looking at Charles and Boyle's law, beginning with this guy right here, Mr. Robert Boyle, obviously the founder of Boyle's law. We're going to look at some background on him. In the 1660s, Boyle used a J tube, an instrument, in order to measure the volume of mercury at different pressures. And so he noticed that these two variables were inversely related, meaning that if volume was increased, pressure would be decreased, and vice versa. This is Boyle's law, and the explanation for it is that as the volume decreases, the gas particles within the container are more crowded, they experience more collisions with the wall, and this is going to increase the overall pressure. So the equation involved with Boyle's law here, this is a nice diagram to help you out, is that P1 times V1 equals P2 times V2. So again, we have to enforce that this only works when temperature and number of moles are held constant, because these are variables that could also impact pressure and volume. And so here's an example problem that you can read. So we basically have a volume of 4 with a pressure of 1.5, and then what's going to happen if the volume is decreased to 3 liters now. And so we're obviously looking for the second pressure here in this equation. We plug in our variables and we multiply 1.5 times 4 divided by 3, and our answer is 2 atm. So now we're going to move on to Charles' law, and Charles studied instead temperature and volume, and this time pressure and number of moles are held constant to make sure the data is correct, and he discovered that these variables are actually directly related, so that when temperature is increased, volume will also be increased and vice versa. And the explanation for this is that as temperature within a container increases, the kinetic energy increases, meaning the particles will move faster, there will be more collisions, this will increase pressure, and in order to keep the pressure constant here, the volume will need to increase as well to balance it out. And so here's a graph to help you out. You can see here, this is volume, it's increasing as the temperature here is also increasing. And now we're going to be looking at the equation within Charles' law. This time it's going to be V1 over T1 equals V2 over T2, and we're going to be looking at this example here on a summer day, 42 degrees Celsius, 4-liter balloon. What happens when it's negative 30 degrees Celsius? Well, we're going to plug everything into our equation. We're looking for the second volume here, and our answer is going to be 3.08 when you do all the math. And keep in mind I changed it to kelvins here because we had a negative 30 and that gets confusing, but as long as you have the same Fahrenheit, Celsius, or Kelvin on both sides, it should all work out. So yeah, I hope this helped.